x. So here they given entire real line. So minus infinity to plus infinity. Then take here at 2. X equal to 2 and lesser than 2. They given the function is x cube minus 3. Okay, here it is clearly x cube minus 3. X cube minus 3 for lesser than 2. So x lesser than 2. And at x is equal to 2 also the function will be x cube minus 3. And greater than, here it is x greater than 2. The function will be x square plus 1. Nothing but how many cases? Just 3 cases. One is x lesser than 2 and x is equal to 2 and x greater than 2. 3 cases will be there. So this x value, x is equal to 2, then lesser than 2, I want to take as k lesser than 2, k equal to 2, k greater than 2, you can take like that. First, case 1. Case 1, I am taking the condition is here, k is lesser than 2. K lesser than, only lesser than, it is not equal. So lesser than 2. What is the function when k lesser than 2? F of x value is x cube minus 3. Okay. So here we are having only one function. We can apply the first formula. Now limit extends to, I want to take k. So why should we consider it is k? Lesser than 2. Lesser than 2 means what is the value at for what value we need to check that continuity. It may be lesser than 2 means it may be 1, it may be 0, it may be minus 1, minus 2, till minus infinity. So in general that value I want to take as k. So limit extends to k f of x. This is equal to limit extends to k. K is any value lesser than 2. K is a value which is lesser than 2. So f of x means x cube minus 3. Actually this is LHS, yes or no? Now this is equal to k cube minus 3. This is the limit value, limit extends to k f of x. I'm using the first formula here. Okay, then we got the limit value. This is LHS. Either you can write LHS or simply you can find limit. No problem, right? Next, RHS. RHS nothing but f of x is given. Just to find f of k. F of x is x cube minus 3. F of k is k cube minus 3. See here clearly LHS equal to RHS. Therefore, limit extends to k. F of x is equal to f of k. Then f is continuous. Continuous at k lesser than 2. Okay, first case it is continuous. Now case 2. Case 1 complete. Now I'm going to write case 2. Case 2 is here. K is equal to 2. First case is lesser than 2. Next equal to 2. Next greater than 2. Okay, at x is equal to 2, if you see here, at x is equal to 2, there are two different functions. At x is equal to 2, see, don't think that equal to 2, sir, you write just x cube minus 3. So then why again you are taking two functions? Not like that here. At that particular value, we need to find right hand limit as well as left hand limit. Nothing but left hand continuous, right hand continuous. Okay. So 2 minus x cube minus 3, 2 plus x square plus 1. That's it. And f of 2 also they given at 2, they given x cube minus 3. Okay, so here again, now when k is equal to 2, k is equal to 2 or x is equal to 2, x is equal to 2, the function value is what? F of 2 is what? X cube minus 3, that is 2 cube minus 3, that is equal to 8 minus 3, it is 5. Okay, now LHC, left hand continuity, limit extends to 2 minus f of x. At 2, at k is equal to 2, we need to find the left hand limit, right hand limit. Right, limit extends to 2 minus means left hand, lesser than condition. 2 lesser than 2. I mean, x lesser than 2. What is the function value? X cube minus 3. Right. So this is equal to 2 cube minus 3. That is again 5. So left hand continuity also we got as 5. Then RHC. Okay. So that is limit extends to 2 plus f of x. Limit extends to 2 plus. When 2 plus means greater than 2 x square plus 1. So 2 square plus 1 is equal to 5. So what do you understood here? In case 2, clearly here we got like left hand limit, left hand continuity should be equal to right hand continuity should be equal to f of 2. Here you should write like limit extends to 2 minus f of x. So limit extends to 2 plus f of x clearly equal to f of 2. Therefore, so what we can write here, therefore, f of x is continuous at x is equal to 2. Okay, students, having any doubts in this? In the same way, how to do all the remaining questions, right? That is the reason I am writing each and every step here, right? Now, case 2 completed. Case 1 is lesser than 2. Case 2 is equal to 2. Case 3 is what? Greater than 2. Case 3. If k is greater than 2, sorry, greater than 2. So let's see here when greater than 2, whether it is continuous or not. So what is the function value when k is greater than 2? X square plus 1. Okay, now we have to find LHS. We can use the first formula alone. At a greater than 2 condition, at a greater than 2, they given how many functions? Only one function. Lesser than 2, they given only one function. Greater than 2, they given only one function. But at 2, we having two functions because the particular value is 2. Now, f of 2, like see, it's better to greater than 2 means k value might be 3, 4, 5 up to plus infinity. It's better to you can find f of k. F of k square plus 1. This is actually RHS. Now limit value, limit extends to k. F of x also you should find. Limit extends to k. F of x value is x square plus 1. So k square plus 1. See, therefore, limit extends to k. F of x value we got as f of t. Clear, students? Therefore, what we can conclude here? Because why should we take like here extends to k. Why don't we take 2? No, we should not take 2 because k greater than 2 means what is the k value? A k having infinite values. So in general, you can take, it's better to find the continuity at k alone, right? So limit extends to k, f of x value is f of k. We can do in the case of only greater than lesser than. In lesser than 2 also what we done? Same, we found that limit extends to k f of x value. That's it. But at equal to 2, you should find the left hand continuity, right hand continuity at that particular point, at that particular value, right? That's it. Any doubts?
Sir, you can show case, please.
Greater than, lesser than, you can find the limit value at k. See, continuity, because continuity is depending on the limit. With the help of the limit only, we are checking the continuity here. Limit LT extends to k. Okay, let's go once again. What about question number? Do you have any doubts regarding to 14, 15, 16? How many cases we are going to get here? First, here, k lesser than -1. We have to check the limit at extends to k. Lesser than is there, lesser than. Then f of x, you can check that whether it is equal to f of k or not. First formula. Next, k is equal to -1. Now in this case, you can find left hand continuity, right hand continuity, and f of -1. Okay, at this particular point, you can find limit, like limit extends to -1 minus -1 plus. Next, k is greater than, right, like k value lies between greater than -1, lesser than or equal to +1. Here k. Here also same formula. First formula you can apply. Just limit extends to k f of x, because clearly 2x is a polynomial, it is continuous. Then here x is equal to 1 or k is equal to 1. K lesser than -1, k is equal to -1, -1 to +1, k is equal to 1, k greater than 1. So these many cases here, at -1 equal to, at k is equal to 1 alone, you can use second formula. Remaining all the cases, you can use the first formula. So what about this question number 17? Whether is it completed or not? Yes? Not completed. Okay, find the relation between A and B so that f is defined by. '17. So first we have to write the given function. What is the function value? Ax plus 1. Ax plus 1. Now bx plus 3. X lesser than or equal to 3. If x lesser than or equal to 3. If x greater than 3. Okay. So what they given clearly here? Clearly it is continuous at x is equal to 3. Continuous at x is equal to 3. So in solution, how to write? Clearly f of x is continuous at x is equal to 3. That is, limit x tends to 3 minus f of x clearly equal to limit x tends to 3 plus f of x clearly equal to f of 3. Am I right? Because they given function is continuous at 3. At 3. Okay. So clearly left hand continuity should be equal to right hand continuity should be equal to the function at 3. Fine. Okay, students. Now we can use this condition. First, I want to find left hand continuity. Limit x tends to 3 minus f of x. Limit x tends to 3 minus. So 3 minus means lesser than condition. This is nothing but 3 minus. This is 3 plus. Okay, what is the function value? F of x value is ax plus 1. Right? Substitute in place of x3. So a into 3 plus 1. That is 3a plus 1. This is limit x tends to 3 minus left hand continuity. Next, we have to find the right hand continuity. That is limit x tends to 3 plus f of x. 3 plus f of x. So this is limit x tends to 3 plus, what is the function value? 3 plus means greater than 3. Greater than 3, bx plus 3. Bx plus 3. This is function value. Now in place of x substitute 3. So 3b plus 3. Shall I write like this? P into 3, 3b plus 3. So this is the RHC. Now clearly LHC equal to RHC. Left hand continuity should be equal to right hand continuity. So 3a plus 1 should be equal to 3b plus 3. Right? Now 3a is equal to, take plus 1 right side, 3b plus 3 minus 1. Nothing but I want to find just a value. So for that, what I want to do is I want to dividing with 3. Each and every term with 3. So a is clearly equal to b plus 2 by 3. So this is the relation between a and b. Clear, students? Because in question itself they given it is continuous at x is equal to 3. This is the formula because at a particular value they given continuity. At 3 there are two different cases, so that use second formula. Any doubts? Next, 18. So what value of lambda is a function defined by f of x is equal to this? Now first write the given function. Write the given function. Lambda times of x square minus 2x. X lesser than or equal to 0. And next one is 4x plus 1. X greater than 0. Fine. So clearly it is continuous at x is equal to 0. Then what about continuity at x is equal to 1? Okay, let us see. This is later. First, they given it is continuous at x is equal to 0. Then we have to write the condition again. We have otherwise you can write clearly f of x f of x solution, given that f of x is continuous at x is equal to 0. Now write that limit x tends to 0 minus f of x will be equal to limit x tends to 0 plus f of x, that is equal to f of 0. So we can use this formula, right? We can use this formula, right? Limit x tends to 0, f of, right? So all of you find that, can you tell me what is the left hand limit here? Anyone? Limit x tends to 0 minus. Find this value, limit x tends to 0 minus f of x, that is equal to limit x tends to 0 minus, minus means lesser than case. So that is lambda times of x square minus 2x. Substitute in place of x 0, 0 square minus 2 into 0. So that is clearly 0. So left hand continuity we got as 0. Then we have to find right hand. Limit x tends to 0 plus f of x. This is equal to limit x tends to 0 plus means greater than. Greater than condition 4x plus 1. Okay, what is the question here? For what value of lambda the function defined by continuous at x is equal to 0? Okay. So right hand limit here we got as 4 into 0 plus 1. Then clearly it is equal to 1. See, according to the question, for what value of lambda the given function is continuous, they are asking. And whether it is it continuous at x is equal to 0, particularly they are asking here. They did not given that the function is continuous at x is equal to 0. Students, once you can observe that. Is the given function continuous at x is equal to 0 for what value of lambda? Then look at here. Here we got left hand continuity is 0, right hand continuity is 1. Is there LHC equal to RHC? Yes, 0 is equal to 1.
No, sir.
Already. So therefore LHC not equal to RHC. Okay, so we should not take this condition. Right? We should not take that. We have to check whether it is continuous at x is equal to 0 or not. So there is no value of lambda, such that the function is continuous at x is equal to 0. Okay, here lambda into 0 or 0 into lambda, you can write like this one. Lambda into 0 means actually 0. So 0 into lambda is equal to 1, lambda is equal to 1 by 0, undefined. So that there is no lambda for which the function is continuous at x is equal to 0. No value of lambda. Continuous at x is equal to 0. That's it. Then next one, what about continuity at x is equal to 1? X is equal to 1 means, is it belongs to the first condition or second condition? Is 1 is greater than 0 or lesser than 0?
Second condition.
Yeah, 1 is greater than 0. So it is belongs to second. So what is the function when x is equal to 1? X is equal to 1, the function is at x is equal to 1, the function value is 4x plus 1. Only one function. It is linear. We know that every linear is always continuous, but we cannot write directly. So limit x tends to 1. Use first formula. That is LHS. Limit x tends to 1 f of x. Limit x tends to 1 f of x value is 4x plus 1. That is 4 into 1. 4 into 1 plus 1. So this is 5. And now RHS, right hand side. That is f of 1. F of 1 is 4 into 1 plus 1. That is equal to 5. Therefore, what do you observe here? Therefore, limit x tends to 1, f of x is equal to f of 1. Hence, it is continuous at x is equal to 1. Okay, because only one function when x greater than 1 at x is equal to 1. Only one function. Is it clear? So clear it is continuous at x is equal to 1. Question number 19. Show that the function, how many problems are there here? 34 overall. Show that the function defined by g of x is equal to
So can you call upon that, sir?
So yesterday I saying that notes as well as recorded video I posted in your classroom like B1, B2, C section separately, not in combined class. Once you can check. Today also I'll post this notes in your classroom.
Thank you, sir.
Right. 19th question. F of g of x is x minus greatest integer function. X minus this. So this will denote, clearly they mentioned in the question. So is discontinuous at all integral points. Yeah, this will denote the greatest integer lesser than or equal to x. Okay. Actually, indirectly, what they given here g of x. G of x means x minus f(x) nothing but this is the fractional part. This is called fractional part. Fractional part is given. Now we have to check, we have to show that the fractional part is discontinuous at every integer, every integral point. At every integer, it is discontinuous. Okay. For example, here itself, see what will happen the greatest integer function. I'm going to explain very clearly. See here. I'm taking the real line. On that, I'm taking a particular integral integer 2. At 2, I want to, we know very well the greatest integer function. Is it continuous? At 2, nothing but we have to find the left hand continuity and right hand continuity. 2 in the sense it's a neighborhood also. If you take any neighborhood of the 2, it should be continuous in its neighborhood also. If it is continuous in its neighborhood, then it is continuous at that integer, right? Since we know that, observe here. So what is the greatest integer of 2 plus? 2 plus means like you can take like a 2.12 till 2.9. I'm taking 2 plus means 2.1. What about the greatest integer of 2.1? Anyone? 2 plus means right hand continuity after 2 I want to check. This is neighborhood. Okay. Yes. Neighborhood point. 2. Okay, 2 plus we got 2. Then you only check 2 minus. 2 minus means left side value of 2. Like I want to take 1.99. Okay, 2 minus means lesser than 2. What is 1.999?
1.
1. So what do you observe here? Right hand limit at 2, left hand limit at 2 are not equal. Not equal. So that here 2 is a integer. At 2, the greatest integer function is not continuous. So not only 2, you can take any integer. It may be 3, 4 up to plus infinity, minus 1, 0, minus 1, minus 2, up to minus infinity. You can take any integer. At that integer, greatest integer function is not continuous. Whenever it is not continuous, x minus the greatest integer also not continuous. No doubt. But how to write mathematically? So we have in solution, you have to write the condition. We have two conditions I am going to write. I want to take n. N is a real number. N is real number. It is equal to n. It is equal to n when it will becomes n. N is an integer. N is an integer, then n is equal to n. So here n minus 1. N minus 1 means this is at n value is how can we write this condition? We can write like this: n minus 1 lesser than or equal to. Otherwise, if you take x here, we'll write it. We'll get two cases here, two different cases. X lesser than n. So clearly, what they given in the question itself, they given very clearly. This will be denote the greatest integer lesser than or equal to x. For example, if I take x value is like n. So n lesser than or equal to x lesser than n plus 1. N minus 1. N minus 1 lesser than or equal to x lesser than n. N minus 2. Like a great, since already we've seen that it is 1 nothing but 1 lesser than or equal to x lesser than or equal to lesser than 2. Here if I write 2 means 2 lesser than or equal to x, lesser than 3. Nothing but from 2 to 2.999, it will be, what about that? It will be clearly 2 alone. In the same way, we can write the remaining also. The same way here also we can write like that. Two cases. N is a integer. For example, n is integer. Then every integer, for example, greatest integer of 2 becomes 2. Nothing but two cases I have written. What I have written here, two cases. This is nothing but n plus. This is nothing but n minus. Means n plus right hand. Here's 2 plus value is we got 2 alone. But 2 minus 1 value is, shall I write here 1 as 2 minus 1? 2 minus 1 as 1. So 2 minus means 2 minus 1. Here n minus. N minus means n minus 1. N plus, here 2 plus is 2. 2 minus is 2 minus 1. Here n minus is n minus 1. Like that. So I am going to write here very clearly the limits. Just to find g of x value is x minus greatest integer of x. Simple. Now you can find that limit extends to, and I want to find n minus f of x. Right, n minus f of x. N is any integer. Let small n is any integer. N is any integer. At that integer, I want to find the limit. So this is limit extends to n minus the function value is clearly x minus step x minus step x. Am I right? So now, yeah, can anyone tell that what about this? Otherwise, if you do one thing, you can take x. X is an integer. X, then x is greater than or equal to n. X is lesser than or equal to lesser than n. X is greater than or equal to n, nothing but like x value is plus n plus more than n. Here n minus. Okay, n minus. Yeah, all of you see here. Substitute in place of x n. N minus this n. So what about the greatest integer value? What is greatest integer when n minus? Can I write directly here? You can write directly also. N minus 1. Okay, n get cancelled. Clearly it is minus into minus plus 1. Once again, I can explain here. See here, I want to find in the question they given, we have to prove that the given function is not continuous, that is discontinuous at all integral points. Integral point at all integers. All integer in the solution. I am taking here n is any integer. Here n is any integer. So at this integer at n, I want to check whether it is continuous or not. Okay. So I'm taking n minus means I'm so sorry, actually time almost to 8 to 9.